your test in Delta Math is on Friday. The only thing after today we have left is word problems. And I know word problems, if you're like me, I hate word problems. So they will be a little more difficult, but if you get the basic skill, you're going to be good. Okay, so make sure your headphones are out, make sure your phones, everything are away, and these are our notes for today, so you're getting this worksheet out. And so what we're doing is these notes have to do with when is it best to use each one, and we already really went over it, so this shouldn't be anything new. So graphing, when is it best to use graphing? When do you think it would be best to use graphing? It's like an obvious answer. Anyone have a guess?
Yeah, I heard it. Somebody said it.
When you have a graph, exactly. When is best to use graphing? When you're provided a graph. If not, that's going to be really messy to have to sit there and do. You can do it, but it's easiest to use graphing when you are provided a graph. It's also easiest to graph when both equations are in slope-intercept form. So y equals mx plus b, that means y is by itself. You can also use substitution, but it's easiest if you're given a graph to do it that way. So let's go over how we graph. Let's look at this first one right here. Who can explain to me how I would graph this first one right here? For a brain bug. How would I go about graphing it? My y-intercept. What is my y-intercept? 9. So it's always that constant, that number by itself. So the first thing you do is plot 9. Then, if it's negative from there, am I going down or up? Down. So I'm going down 3. And if there's no thing underneath it, it's really negative 3 over 1. So I go down 3, 1, 2, 3, always to the right 1. Down 3, 1, 2, 3, over 1. And I just continue it. So do this on your own paper as I'm doing it on the board. This is just review of what you already know. And then you draw a line through it. I think I plotted that one. So it looks something like that. This is the first lesson we learned in Unit 4. To graph the second one, I look and I see, oh, my y-intercept is 4, because Keandra told me it's the number by itself. So I plot 4. And since it's positive, I go up. So I go up 2 over 1. I can stop there. I don't need to keep going. I don't need to keep going because I see it crosses right there. I already found where they cross. What's that x coordinate that they cross at?
7, no, 1 7.
Let me see. I think it's 1 6, yeah. My graphic looks really small, but it is, the x coordinate is 1. The y coordinate is 6. And that's my answer. How can I check my work when I'm like doing a test and I want to make sure my work is right? What can I do with that answer choice? Tristan, what could I do? What's my answer to make sure it's right? Mario, what can I do? Plug it in. Does everyone understand what I mean when I say plug it in? Like take 1, plug it in for x for both of them, and you should get 6 as both your answers. That's how you know it's correct. Cool. Next one is substitution. So substitution is best to use if a variable is by itself already. So it's best to use substitution if one or both equations have a variable isolated. So that just means like if it's y equals or if it's x equals. So it's best to use substitution if it's going to be easy to be able to substitute. So when I look at my example, this is the second lesson we learned. Right here, I could see which of these two equations have already a letter isolated variable. The second equation, right? See how this is y equals 2x plus 4? So I circle that. So I'm just basically reviewing what we did. Then I'm writing the first equation down. And I know, what is that? So I have 3x plus y equals 9. But I know that y's getting tired, right? It's like we have a game, football game. Y's getting tired. I'm going to have to substitute y with what he's equal to. What is he equal to here? Beautiful. So I'm going to write the equation once again, but instead I'm going to use 2x plus 4 for y. And I'm just going to put 1y. So I rewrote it, but instead of y, I put it substituted. Then I solve. So I bring down 3x, and then I distribute 1 times anything is that same number. So you end up getting 2x plus 4 equals 9. Then I need to combine like terms. Jasmine, which two terms can I combine? Yep, 3x and 2x because they're on the same side of the river. What is 3 plus 2? Beautiful. 5x plus 4 equals 9. Then how do I get 4 on the other side? You end up getting 5x equals 5. Then how do you get x by itself? So 9 by 5. You get x equals 1. Am I done now? No. I know my solution. The x is 1. I need to find my y. So Tristan, what do I do to find my y? Notice, Tristan, I'm asking the same question each time. So you could choose either equation to plug it in. The easiest ones probably were, I already have y equals. So y equals 2x plus 4. I already know what my x is. What is my x? Right here, 1. So I'm going to rewrite it, but instead of x, I'm going to put 1. So what is 2 times 1? 2 times 1 plus 4, 6. So I know that my y coordinate is 6. Notice it is the same answer as the So I'm pretty sure these are the same equations written 3 different ways. We're just going over how it's best to use each one. Does that make sense? Okay, last one, elimination. It's best to use elimination when both equations are in what? Beautiful, Martin. Both equations are in standard form. That means that x and y, this is standard form, that just means that x and y are on the same side of the equation. So usually when we are doing this, you aren't going to be able to, they're not going to say use this method. Sometimes they will. So you'll need to know, okay, x and y are on the same side. It's probably easiest to use elimination. And so elimination is the one that probably I would practice the most because sometimes people can get confused about it. So first I look at my x's and my y's and see, are they lined up? Are the x's and the y's lined up together? Yes. Next thing is I need to pick my match. So I need to see, am I going to play around or be a matchmaker for the x's or the y's? The y's, right? They'd probably be easiest. Because I have one y, and you can pick which one you want. And so if one's positive 1y, what does the bottom one need to be? Negative 1y. I could have chosen negative 1y for the top. It doesn't matter which one you choose. You'll get the same answer. So do I need to do anything to the top equation? No. I'm just going to rewrite it. 3x plus 1y equals 9. But what do I need to multiply to 1 to get it to be negative 1? what number can I multiply that just changes the sign? -1. So a negative just changes the sign. And I gotta multiply to all three terms. So what's -1 times 2x? It just changes the sign to positive 2x. This will change to -1, and that changes to -1. Then what do I do between the two equations? Add. And so now I'm eliminating, right? So like if I were to eliminate somebody, that means I'm getting rid of them. So 3 plus 2, that doesn't eliminate. What do I get? What's 3 plus 2? 5x. This eliminates because 1 minus 1 is 0. I get rid of it. And what's 9 minus 4? 5. Then how do I get x by itself? You end up getting x equals 1. Notice it's the same thing as over here because it is the same equation written 3 ways. To get my y, Tristan, what do? Plug it in. So I take either equation, doesn't matter which one. I'll take the first one, 3x plus y equals 9. And instead of x, I'm going to plug in what x equals, which is 1. Then I solve. What's 3 times 1? 3 plus y equals 9. Then I subtract 3 on both sides. What do you get? Y equals? That was basically a synopsis of everything we went through besides the columns. Does anyone have any questions on operators? I also recorded this too, so like if you need to re-listen to it or you forget how to do one, remember that you can just go on Google Classroom and that will be on there. So now what you're doing is you're looking at that next sheet and it's nothing new, it's just practice. So what you're going to be doing is figuring out, okay, which method would I use for each of them? And you're writing it down. Then you're solving. Notice all of them are provided a graph. So remember that when we're looking at graphing, it's best when provided a graph, but also when the equations are in slope intercept form already. So what you're going to be doing, it's just the front and back. You're going to be figuring out which method you use for each, and then solving it that way. So I'm going to give you like 2 minutes just to go through and write down what method you would use for each of them. So don't solve it yet. So you're going through each one and figuring out which method would I use for each of them. So you can use your notes as a cheat sheet. So go through each one on that worksheet. I'll give you like 2 minutes and figure out what. All right, let's go over this. Stephen, what would the first one be? Perfect. Who got that? Substitution. Why would it be substitution? Why would it be substitution? Chose one. Who can help Stephen out? Why would it be substitution? Keandre. One or both equations. So we can see that this one has a variable isolated, so it'd be easy to substitute in for y. Perfect. You can raise your hand and tell me that actually I'm going to call the next one. For Tiana, what did you get for the next one? Graphing. So it would be easier to graph here, especially because there's a fraction involved. You could also use substitution, but you would probably want to turn the fraction into a decimal. So I would take graphing. You can also put substitution because one or both are solved for a variable. Tyreek, what about 3? Elimination. Why did you choose elimination? Good. The equations are in standard form. Both x and y are on the same side. Perfect. Next one. Damon, did you get the next one? Nope. Jordan, what about you? Did you get the next one? What would you get? What did you use? Substitution. Why, Jordan? Yeah, because y is by itself right there. Perfect. Angel, what about the next one? Elimination. Those are in standard form. Oh, one more. Victor, what was the last one? Graphing or substitution, but it's probably easier graph. Perfect. So now you're just gonna spend the rest of the period and you're just solving it. You do not have a ticket out the door today because this is a good practice for your quiz. So once you're done with this, the answers are up here, but I just have the answers. Like I don't have the work or anything. So that way I can see like that you're solving it and getting the correct answer. Once you're done, you can work on your Delta Math homework. Any questions on this?